Hey everybody, let's take a look at the next subject we're going to need to learn. And we're actually going to do a linear regression of our own in this tutorial. But first, you need to look at Python arrays. Now we saw lists in the last tutorial that you looked at, that hopefully you're finished with. If you didn't do that tutorial, you really should go back and look at this. That's the previous activity for this week. And so what I want to show you is a little bit of a more powerful way of dealing with more than one number at a time. As you know, lists allowed you to deal with more than one number, like the numbers 1 through 20, or the even numbers between 1 and 20, etc., right? Or any collection of numbers. It might be your data, right? So that's really cool. Lists are very useful, but I think that arrays, which are kind of a little bit more sophisticated type of object in Python, it just has a lot more methods. Remember what a method was? So a method can go with a certain type of data. So it's much more useful. And to use arrays, we use a library in Python called NumPy. So that's N-U-M-P-Y. Now you've probably, if you've looked at any of the code in the book, you'll see NumPy because it is absolutely necessary for pretty much all data science and machine learning code that you might run. So the way that we get it into a Google Colab is we'll put import. So this tells Google Colab to import a library, so whatever you tell it to import. And NumPy is the name of the library. And we say as, so that we can give it a nickname so we don't have to keep typing NumPy, okay? You can give it whatever, you can call it Fred if you like, right? But most people just call it NP for NumPy. And so let's just start with that, and there we go. Give it a second. It's the first command. It always takes a little while. There we go. So now we have NumPy. So we have all the things in NumPy, all the methods and stuff to use in NumPy. All right, so what do we want to do? Well, I'm going to get a little code block here. We'd like to just look at what an array is. Okay? All right, so I'm just going to call capital X, and I'm going to make an array. There's a keyword, array, in NumPy, and the way you call it is you call the library and then the method. And you can see there's a lot of methods, right? So if I scroll down on these methods, remember how this pops up and tells you every little thing, right? A lot. Yeah, there it is, array, okay? I don't have to scroll down to get it. I could just start typing, right? Whoops, right? And it pulls it up for me. And the way that you're going to, so remember when we did lists, you just wrote down the lists in the square brackets, right? In this, for an array, you need, this is actually a function, and inside there you put the square brackets, and you tell it the numbers you want to be in your array. So for instance, 1, 2, 3, 4, 5. Sure. Okay. So those are my. It's kind of like you have a list in the array, and in fact, you can declare this stuff as a list first, and then pass it into that. And I'll just show you that in a second. But let's just run this. Okay. There we go. And now, if we just type X, I think it'll print it out for us. There we go. And it says, hey, that's an array object. And it looks like this. It has these numbers in it. Okay. Let's try doing it as a list. That might be useful sometime for you. So let's say A equals, or how about my list equals 2, 3, 4, 5, 6. Okay, there we go. And then let's just run it, make sure everything's okay. Uh-oh, let's see, what did I do? Oh yeah, guess what I did? I hope you could pause the video and try to figure out what did you do wrong. Okay, I'm back. Hopefully you paused the video and you figured out that I left out my commas. And this is kind of a common error for us MATLAB programmers who are used to not having to put commas anywhere. Anyway, okay, there we go. So there's my list. And now I could say, new X, okay, is equal to np.array. Again, remember the array function is a method of NumPy, and I just put the name of my list, okay? Let's see what happens here, okay? Let's just see what's in newx now, okay? And there we go, okay? So there's a couple of ways to make it. But look at the syntax. Remember, array is a function, so it has the NumPy, it's one of NumPy's functions, methods, and you have to use the parentheses, and inside you put the square bracket, right? It's kind of like you're sticking a list inside, and then NumPy makes an array for you. Again, array is just a fancy word for a list, but it can be even more interesting than lists, and it's faster to process than lists. So if you have to do a lot of operations on your list, you saw the last tutorial that you were doing some operations on the numbers in your list, that it can be much faster to process. Also, you can have multi-dimensional arrays, which we'll talk about in a little bit. Okay, so let's set up, and I'm going to show you a couple of things. One thing is I'm going to show you something called shape. So I'm going to get another bit of code here. And as always, you should be following along and trying what I'm doing, making your own little changes, right? See if you can get what you'd like to run on here. Okay, let's look at a method of array. So again, now that x and newx are both NumPy arrays, right? I have all kinds of methods that I can use on them. Okay, for instance, I'm going to say print. I want you to show me the shape of this array. Okay, maybe you're like, what does that mean? Well, let's look and see what happens. Okay, it says 5, nothing. Okay, and in NumPy, it's a little strange. It's a little different from other programming language. In other programming languages, it doesn't really matter, but you'll see what I mean in a bit. So what it's telling me is that the shape of X is that it just has 5 columns, right? And so 5 numbers, and it doesn't have any other rows. Okay, so this is a little bit weird, and it's I think you'll get used to it. But we're going to make an array that has more. It has more like rows and columns. We'll show that in a minute. And I think you'll understand the shape a little bit better once we do that. Okay. So let's take a look. All right, let's make another array. I'm going to make another code block. I like to make extra code blocks so I don't have to run a bunch of stuff that I've already run. But anyway, you can put it all in one code block if you like. Okay. All right, so let's just make another array, and I'm going to just call it new R. And now I'm going to make it, I have to say np.array because that's how I tell Python that I want to make a NumPy array. And I'm going to make a 2-dimensional array. So what I'm going to do is I'm going to start with 2 brackets, and I'm going to give it 2 values, and then I'm going to put a comma. And you're going to see what I'm doing here in a second. Whoops, I meant to be 2, and comma, 2, 3. Okay, so let's push that and make that array. Oops, didn't like it. What did I do wrong? Let's see. Yep, I did it again. That's my MATLAB programming coming in. Again, pause the video whenever you see me make an error like that. Pause the video so you can figure out what I did wrong. It's good practice. I just left out a comma, by the way. Okay. All right. So now let's look at the shape of this. Print new r.shape. Okay. What's it going to tell us? 4 by 2. Okay. So what is that telling us? That tells us there are 4. Right? There are 4 columns and 2 rows, okay? So it's kind of an interesting way of with arrays, you could make multi-dimensional things like this is a little matrix. Okay, so I will show you a little graphic that might help you understand this whole multi-dimensional arrays. Okay, so I brought up here, and I actually have to stop the share for a second and come back to the share. So give me a second here. Let me go share my screen and share again. Okay, so I brought up a little graphic here, and I just lost it again. Here it is. That could shows you a little bit about what shape does. So for instance, the first array that we made, this one up here, or this one new x or x, right? When we did the shape of x, we got 5 comma nothing, right? So similar to this has 4 elements, and you get the shape gives you 4 comma nothing, right? So this is a one-dimensional. This is what Python calls a one-dimensional array. Okay, it only has one row, or it could have one column, right? But in this case, it's a row. All right, now what about a 2D array? So look at this, right? It looks like a little matrix, right? Or a little spreadsheet where these are the columns and these are the numbers that come down the columns, right? Okay, so it has 2 rows, 1, 2, and 3 columns, 1, 2, 3. Okay, so notice over here we have 4 rows according to this. So it looks a little weird the way that we wrote it down. And we have 2 columns. So it's really hard to tell if you make an array in this way what the shape is. So knowing how that, checking your shape, making sure it's what you want, right? If you want 4 rows and 2 columns, okay, then this is good. But maybe you entered your array and that's not what you want. You want, 2 rows and 4 columns, right? All right, so always check with shape that you got what you want. All right, now there of course are, any dimensional array that you want in Python. For instance, 3D, right, would have, say this one has 4 rows, 3 columns, right? So here's row 1, 2, 3, 4, and then it has 3 columns, 1, 2, 3, and then it has 2, it's 2 deep, right? So there's 1, 2. So think of it as being sort of like you take the whole matrix, right? And then you have 1 and then 1 behind it, kind of like files in a file drawer, right? So there's 2, it's 2 deep. There's 1, 2, right? So it's like 2 full matrices deep. Okay. It's a little hard to understand this when you look at a 3D thing, but the idea here, why there's 2 here, 2 here, 2 here, is that there's 2 in that slot, right? So if that corner slot has a 2 in it, right? Okay. Just never mind that it looks like those 2s are on the face of that little cube. It means that there's a 2 in that corner. Okay, this is trying to visualize things even in 3D is a little bit hard for groups of numbers. Okay, but in machine learning, we very often have more than 3D arrays and so on, which you can't represent on a picture like this. Okay, all right. So if we go back to this example, just to, be a little clearer about how you write them in. If you want to write, want to write by hand an array like this. So for instance, think of it this way, right? This is a little row, right? And this is 1 row, so it has 2 columns, 1 here, 1 here. So this number's in the first column, this number's in the second column. Okay, like a spreadsheet. And now go down to the next row, and that would be this one. This one's in the first column, this one's in the second column, and down to the next row, that'd be this. This is in the first column, this is in the second column, right? And then the next row, this is the first column, second column. So that's how you'd write it by hand. It just looks a little funky, it doesn't really show you the shape very well in this format. That's why shape is a good thing to check. Okay, give me a second here. All right, so let's actually go through an example of a linear regression like the one that is done in chapter 1. because we're building up to on Friday when we're going to actually get that code running for ourselves. Okay, the code that does the fit of the life satisfaction to the GDP, as we saw before. And so let's actually do an example of a linear regression. Now to do that, I need to import some methods from the sklearn library. So if you notice on your book has sklearn in the title, right? Because it tells you you're going to be using sklearn and TensorFlow to do machine learning. So sklearn is yet another Python library. And what we're going to do is we're going to come back up here, because I like to import all the libraries up at the top. Now that's not always true. You'll see people, I might import libraries from somewhere else in the code. But I kind of like at least the big ones to be up at the top. Again, this is not, you have to import them before you use them, meaning they've got to be before any code, right? So in other words, they have to be above any code that uses those libraries. Otherwise, Python's not going to know what you're talking about, right? But if you wanted to import the code somewhere farther down, so in other words, I could import the code down here. I can import sklearn down here because I haven't used it yet, and I'm going to use it after that. But I just, for cleanliness, like it to be at the top. Okay, so this is a little different the way we're importing this, because we're going to only import some of sklearn for this. So I'm going to say from sklearn dot linear model, and then so there's linear model is one of the methods of sklearn, and it has a lot of sub methods in its own right. Okay, so I'm gonna say import linear regression. Okay, so what that does is it allows me to just call linear regression and not sklearn dot linear model dot linear regression. I can just call linear regression by itself. It's just a shortcut. In other words, I don't have to type as much. Okay, which is always good in coding, so you don't make mistakes. Okay, see, like this. Okay, what's the problem? I probably spelled something wrong. You should go and check out what I might have done wrong. So take a good look at it. I already know what I did wrong, but pause the video and see if you can figure it out. It's this problem, right? So you can see where it shows you. There's the error. Something in there was wrong. Okay. All right. I'm going to fix it now. I forgot an R. Okay. Okay. All right, great. So now we have our linear regression methods that we might need. All right. I'm actually going to keep my X array here. And I'm going to just get rid of all this because I don't need all this. This was just for playing around with arrays. And let me rerun it here. There we go. Now the issue with our linear regression is that it needs the X values in a very particular way. So remember when we did print x.shape, we got that it has 5 rows, okay, and nothing, right? No columns, even though really it kind of has 1 column, but never mind, that's just a fluke of Python. Anyway, the linear regression method has to have X in a really very particular shape, and it has to be what Python considers a 2D array. Remember that picture we saw, where it has 5 rows and 1 column, even though this looks like it has 5 rows and 1 column, right? It kind of looks like that's, what else could it be? You have linear regression, those methods needed to have a very particular shape, and that shape is 5, 1, not 5, nothing. Okay, so there's a way to make it do that, and that's called the reshape function. And so I'm just going to say x equals x.reshape, and then I'm going to say I need it to be the length of x. I'll explain that in a minute. I don't know if we did the length already. So it needs to be 5 rows and 1 column. So reshape it so that it comes out that way. Let's see what happens. Okay, and now I'm going to print the shape again. Okay, and now we have in the correct shape. Now this length function, this is just a function that says how long is it? Well, it's 5 long, right? Okay. All right, so this you always have to do have it in the right shape. So certain functions have to have the data in a particular shape, and by shape, it's what Python thinks the actual shape is, right? So even though this looks like it certainly has 5 numbers, and if this is a row, this is a row, this is a row, this is a row, and this is a row, I think of numbers down in a spreadsheet. Python doesn't really think that's the case. It's a little weird, okay? So you have to reshape it so that it thinks that it's this 2D array with 5 rows and 1 column. Okay, a little strange. And let me show you something. So if I print X like this, right? Hello. Oh, yeah, that's the thing where Colab doesn't print it out unless it's the last thing in a code block. But I can print this. Print, just to show you. Okay, so this is before the reshape. Now look at what happens after the reshape. Notice it really looks now like 5 rows and 1 column. Okay, so it is different. I find it a little odd. It's just the way it is. But this, really looks like 5 rows and 1 column, right? Okay. All right. Anyway, anytime you're going into linear regression, again, I don't expect you to write your own code. I'm going into a lot of depth in this just to give you like a little bit of breadth in the very first thing we do, and one of the simplest things we'll probably do. As we move on, knowing how to call the functions is important. So in this, the reason I'm going on and on about this here is that you have to know how to make your data look right to get into the functions. Okay. All right. All right. So now let's do some plotting. Okay. And I'm going to get rid of some of these. I'm going to trash these guys. Okay. And I'm going to get some code again. And I'm going to now import matplotlib. Okay, so first thing I'm going to do is I'm going to use this matplotlib inline, which just tells it how I want to call it. I didn't spell it right. Can't spell. Okay, and then I'm going to import the library. Import matplotlib as MPL. Okay. Okay, we're good. And now I want to just do a scatter plot. So I'm going to say MPL, so matplotlib dot pyplot, okay, dot scatter. So pyplot is a method, and then the sub method is scatter. It gives me a scatter plot. And I want to do X, and so we also need a Y, so we haven't done that yet. So maybe we should do that before we try to plot this. Okay, let's get a Y. All right. So remember in list there was a way to do something on to do some mathematical operation on everything in a list. Same thing in Python. You can do the same thing. So let's do Y equals NP dot array. So now we're saying we want the output to be an array. And what we want you to do is we want you to do I'm going to do this mathematical operation, times X, whoops, capital X, no, little x, plus 3 for X in big X. So that's a bit confusing, I realize, so let me explain here. And I'm going to use a different variable because I feel like it's just too confusing with little x's and big x's. So I'll put 2a. So what's happening here? This here is saying, hey, I want you to do this operation multiply a by 2, add 3 for every a in x. And remember, we saw that in before in a previous tutorial, like what does it do? And so it's actually going to go through every single value in x stored in the variable a and do this to it and put it all out into an array called y. Okay, so for instance, the first thing in x, right, is this number 1. Okay, it's going to store 1 in a, then it's going to multiply a by 2 and add 3. And so it's going to get 5, right? Yeah, so 2 times 1 is 2, plus 3 is 5. And the first value of y in that array will be 5. And then the next one will be 2. So it'll put the 2 in a, it'll multiply a by 2, get 4, and add 3 and get 7. So the second thing in y, in the y array, will be 7. And I'll just do this for all of them. It's just fast, so you don't have to do it yourself. All right, so let's see what happens. Let's actually print out y. Okay. There we go. And look, it's 5, 7, 9, 11, 13, right? Okay. And now we can actually put this in our scatter plot because we need x, y for the scatter plot, right? Okay. Let's do it. And there it is. Certainly looks like a nice straight line data, right? So I actually told it to make a line because this is like mx plus b, right? That same, remember a straight line has the equation y equals mx plus b. A is like x, this is like m, the slope, and this 3 is like the intercept, right? Is the y-intercept. And here we go, certainly looks linear, right? Okay, so now we would like to actually execute the linear regression. Get another piece of code here. And I'm going to call my linear regression function. And I'm going to call it reg for regression equals linear, and pops right up. And then I have to use the little brackets, dot fit, and then I say, I want it to fit x and y. I want to fit this data that's in the scatter plot. Okay, and let's see what happens. Okay, well it didn't biff, that's excellent. And now I'd like to know what coefficients it found. So in other words, what did it find for the slope? Okay, and so to do that, I put reg and then dot coef, and it comes right up here. Okay, and what did it find for the slope? 2, right? So 2, of course, because we told it the slope was 2 when we made it, right? Well, we didn't tell the regression was 2, but certainly when we made it, we made a 2, right? We made the slope 2 because anything, whatever's multiplying your independent variable is the slope of the line. And you can prove to yourself just looking at it, right? How do we figure out what slope is? Well, look at one of the lines that looks like roughly 9, right, minus, right? So this is 9 minus 7, which is 2, over 3 minus 2, which is 1, right? So rise over the run, and it certainly is 2. And that's exactly what the linear regression fit found for this data. No surprise, the data is perfectly linear, right? And as we've seen in our other tutorials in the Khan Academy, you could have data scattered all over the place and certainly wouldn't be linear, or maybe it's scattered but pretty linear and you could fit a good line in there. This one we made with perfect data, so of course it's going to find that slope. Now what about the y-intercept 3? Where is that? Why didn't it tell us when I said give me the coefficients of your fit? Why didn't it tell us the intercept? Well, it doesn't work that way. So if you want the intercept, you have to use the predict, and I'm going to show you that next. All right, so let's take a look at that. First, I'm going to change this down here to say print, so that this keeps printing out our slope. And then I'm going to show you what we do to get the intercept. Now, this is really called, this can be used to get any value you like. So in other words, given an x value, this could be used to get any y value from the fit, right? So there's a line, obviously, that you could draw through this. And what if you want the value at 2.5, right? Well, let's see. Let's use the predict function to do that. So I'm going to say print reg.predict. So this is one of those methods of this linear regression. And then I have to give it a number that's in an array. Now, it's meant to be called, or it's built so it can be called with an array of numbers, because maybe you don't want to just predict one value. You want to predict, you have a lot of x values and you want to predict their y values, right? From this fit, from this line, right? That it fit to these data. So it's meant to really take an array data. So if we actually give it one number, I have to actually make it look like an array with these brackets, okay? And now I can put in 0, let's say, or actually, no, we were going to do 2.5, right? So you see the double brackets around it? That's saying, hey, I'm an array. I have one row and one column, right? Okay. And let's see what happens. Oh, I did an error again. Let's see. Stop and see if you can find my error. Okay, I'm going to fix it. There we go. So it said 8. So at 2.5, it thinks we should get an 8. Well, let's look. Well, that looks about right, doesn't it? At x equal 2.5, yep, we should get 8. But remember, I was interested in the intercept. So I want to know what is the value of the function when x is equal to 0. That is what's called the y-intercept, right? And we know it's supposed to be 3 because we made it 3 when we made our equation. So I'm going to put in a 0 here and see what happens. And there it is, 3, right? So the slope is 2 and the intercept is 3. Okay, and you can see that's what we made when we did here. 2 times a plus 3, right? We made that line. Okay, so there are 2 things you need to do for this activity. One is recreate this and share it with me. 2, you need to alter this, right, to put in your own data and make a fit. Now, what I suggest that will get you the highest grade is to go and use something like Desmos. If you've ever used that, that's an online graphing calculator. It's really fun. I'll show you really quick. To look at a line, so Desmos, there we go, graphing calculator. It's really fun. You can put down, values down here. Oops, I didn't want to go. You can put in a line like y equals 6x plus 2, right? And it shows that line, see? And you can see what that line is going to be, and you can see what points on that line. And you can also decide on points that are not on that line, because maybe you want to, the best grade you can get on this assignment is to make up some points that are linear but not exactly on a line, right? So we saw again when we were doing the Khan Academy videos that your points can be scattered around and still maybe you got a good, nice fit. So for instance, you could do, 3, I want to put a point down. Let's see, how about 0.1 for x and 2.1 for y. And do you see that point that just popped up? It's blue, right? So you can see it's right here, right? Because you can see it tells you it's a blue point, right? And it tells you it's a point on a line that says, hey, it's a function or a line. This just means any old function, right? See that point right there? And you can see, oh yeah, that looks like it should be online, but it's not. So it's kind of my fake data. So you can make fake data with the Desmos calculator, right? And then enter that data in your Python code, right? This would be one of the X values and this would be the Y values. All right, so that, I will leave that to you. Please email me with questions or problems with this. Again, the highest level grade will be if you make something that doesn't look just so perfectly linear as this, to test your skills with making this linear regression work. All right, I know this is a little bit of a challenge. I know you can do it. All right, see you later.